Thank you very much, Konnichiwa, and domo arigato gozaimasu for inviting me to be with you today. So, my friends Yuko and Masami both invited me to share some thoughts with you on health and on the issue of plastic chemicals for the Global Plastics Treaty. So this is just to give you an overview of the topics that I would like to address today. And yeah, I think we'll get right started with the introduction to the Global Plastics Treaty. So plastics are very present in our daily lives. They're used very extensively to package food. And this is a picture from a supermarket that could be taken anywhere in the world. Our food system very much depends on plastic packaging today. And about 40% of global plastics production, which is over 400 million tons per year, is used for packaging. And I estimate that about 10 to 20% of the total plastics produced goes into food packaging. And we can see this. This is a picture, I believe, that was taken in Indonesia, but you can really go to any coastal area in the world almost. We see a lot of plastic packaging making up a big majority of the plastic pollution that we see. And these are data from 2023 beach cleanups. Collected by the Ocean Conservancy, and here you can see in the top 10, in the top 10, most of the items that have been collected are food packaging items. So as Nakashita-san already mentioned, the world is currently negotiating the Global Plastics Treaty. And this is from March 2022, when at the United Nations Environment Assembly, the member states agreed to negotiate this treaty. This is a timeline since the UNEA decision. And right now we are here in this timeline. So we're just ahead of INC 5 that is starting in 2 weeks' time. And this was just for you to see, this is the resolution that was passed in March 2022 by the United Nations Environment Assembly that clearly states the scope of the treaty, and it clearly states to prevent plastic pollution and its related risks to human health and adverse effects on human well-being and the environment. So human health is clearly within the scope of the treaty. So for the treaty to be effective, it needs to address chemicals and health as key issues across all life stages of plastics. This is very important. So which life stages matter the most for direct chemical exposures to plastic chemicals? It's these 4. It's extraction and transport, where not only occupational exposures, so exposures to workers occur, but also to communities that are so-called fence line communities. So communities that are very close to these extraction sites. Then, of course, during manufacture and production of plastic materials and products, again, occupational exposure, but also, again, fence line communities and communities living downstream of these manufacturing sites are affected. Then, of course, the use phase, when citizens or consumers, as they're often called, use products and materials. And I know that you're very aware of this. For example, this phenomenon of chemicals that migrate or leach from plastic food packaging into food, for example, which then are ingested with the foodstuff. And then the issue of waste management, which I think for many member states initially was the main focus of the treaty. And of course, there are a lot of impacts on human health, for example, from open burning, which is practiced in a lot of developing countries just to get rid of plastic waste. This causes dioxins, for example, to be emitted, and dioxins are very persistent chemicals, so they will accumulate not only in the regions where plastics are open burned, but globally. But also the issue of toxic recycling is very important. And I just want to tell you one story from Switzerland, where I live, where we incinerate most of our plastic waste. And there's an incinerator in the city of Lausanne that has been producing dioxins which have not been removed from the exhausts of this incinerator. And so as a consequence now, the municipality of Lausanne recommends that citizens do not consume vegetables grown in their own gardens because of the high levels of dioxins. So this shows you that operating incineration plants is very, very challenging. And another solution that we hear a lot about in the treaty now is recycling. And the reason why I and other colleagues are very concerned about recycling as a solution is that plastics don't only leach chemicals into food, but they can also absorb chemicals. And so when we recycle, we have to be very, very, very careful that we do not contaminate the materials with hazardous, even more hazardous chemicals. And what our work has shown is that recycled plastics actually tend to contain higher levels of hazardous chemicals and also different types of hazardous chemicals like bisphenol A, for example, have been found in recycled PET. So let's take a look now at what plastic chemicals we know about. And this is going to show you the findings from a report that I collaborated on with several other scientists called the PlasChem report, published in March this year, which gives us the state of the science on plastic chemicals. But then to make a meal that you will enjoy eating, you add the sauce, you add some cheese, you add some salt and pepper and so on. So this finished dish basically is your plastics, because to make plastics a functional material or product even, we need to add a whole bunch of additives. And then through the cooking and the combining all these flavors, we also generate new flavors and tastes, the combinations, but also the chemical reactions that happen. And so those chemicals are then also present in the finished plastics. So plastic chemicals basically are all of these chemicals that are relevant across the entire life stages of plastics. The starting substances, the additives, like pigments, plasticizers, fillers, antioxidants, and so on, processing aids that are used, and then also what we call non-intentionally added substances, or NIAS, which are reaction breakdown products and impurities. All of these are plastic chemicals, and we're interested in all of these. So what are some of the key findings from this PlasChem report? We found that there are over 16,000 plastic chemicals known with an identifier, and that means that there's a CAS number, a chemical abstract services number, which should be unique for each chemical. And in addition, we found about 2,000 additional chemicals or mixtures of chemicals which do not have this unique CAS number, and many of these are oligomers, which are considered to be non-intentionally added substances. They're reaction byproducts of the plastic manufacturer. So as I stressed before already, and I will repeat it again, when we talk about plastic chemicals, we're not only talking about additives. And here you can see some of the different functionalities that these chemicals have. So actually in this picture, most of the ones listed are actually additives, but we also have the monomers, which also are plastic chemicals and which also can leach into food, for example, into the environment, but also catalysts, which are considered processing aids, for example, and then pigments, colorants here, plasticizers, which oftentimes tend to be the focus, and antioxidants are also very, very important additives. And then there's several other functions. There are 2 points that I think are very important to make here. One is that most of these plastic chemicals have a multitude of functions. And they also cover the different life stages of plastics. So catalysts, for example, will also be present in a finished plastic product, even though it does not have a function in the finished product anymore. But one example is PET, leaching of the catalyst antimony. The other point that is also important to make is these are just the known plastic chemicals. I showed you before, 16,000, maybe 18,000 in total. Experts estimate that they may be up to 100,000 plastic chemicals. So most of the plastic chemicals are actually non-intentionally added substances, and most of those are simply unknown to us today. So in the PlastChem project, we wanted to not only identify which are the known plastic chemicals, but we also wanted to identify which of these plastic chemicals are chemicals of concern. And we based this assessment on what we call the PBMT hazard criteria. So we compiled information on whether a plastic chemical is persistent, whether it bioaccumulates, whether there's mobility in the environment. So these are all environmental hazard criteria. And then we also looked at toxicity to human health, which includes carcinogenicity, mutagenicity, toxic to reproduction, and also, of course, endocrine disruption and some other aspects as well. Okay. And so when we compiled these data, we then decided if a chemical has one of these 4 properties, we already considered of concern. So now I will show you the results. We found at least 4,200 plastic chemicals of concern based on this approach. And I want to just highlight here that some of these chemicals were found to be not hazardous, but for no chemical were all the 4 PBMT hazard criteria assessed. So this is an incomplete assessment. And just briefly here, you can see the different kinds of hazard properties, just to highlight here. 47 EDCs, but of course the vast majority of the plastic chemicals have no hazard data, so there likely are more EDCs. And of course EDCs, sorry, I should have said that, refers to endocrine disrupting chemicals. What we also were interested in is what was understanding for which of these chemicals of concern we have evidence that they're actually present or even migrating. And so you can see here that for at least 1,800 chemicals of concern, we know that they are being used or are detected in plastics. And you can see the breakdown of this here. So this is based on empirical evidence. So if we look at the Plastics Treaty again, we can say that most plastic chemicals are currently not addressed under other multilateral environmental agreements, such as the Basel Convention, Stockholm Convention, Minamata Convention, or the Montreal Protocol. In fact, only about 6% of what we identified as plastic chemicals, known plastic chemicals, are globally regulated under existing conventions. So how do we deal with so many chemicals? And this is our proposal for negotiators of the Plastics Treaty to consider. There could be a red list of 3,651 worst chemicals of concern. And then a watch list. These are 28 chemicals that are currently under consideration, for example, under one of the other multilateral environmental agreements. These orange chemicals are chemicals that are thought to be less hazardous, but always based on oftentimes incomplete data sets. And again, these not hazardous assumedly because of incomplete data sets. So this could be an approach how to deal with at least the first chunk of known chemicals of concern. But there's still many, many chemicals on this gray list here for which we have no hazard data at all. So what we did in the PlasChem project was to group chemicals based on their chemical structure, but we also used other approaches, for example, whether they had certain chemical elements like fluorine or tin and so on. And that actually could be a way to deal with chemicals for which we do not have hazard data, namely to then regulate them on this group-based approach. And so applying this approach systematically, we were able to group more than 10,000 chemicals based on their structure. And we identified 15 priority groups of concern where 40% or more of the members in the group were known to be chemicals of concern. So these are our recommendations from the PlasChem report to policymakers, acknowledging that there are many chemicals, and I showed you at least 4,200 are of concern, many more that probably of concern if we take the grouping approach. So I think we need to have international agreement on regulating these plastic chemicals comprehensively and efficiently. Then I also showed you that we have many data gaps, many unknowns, the non-intentionally added substances. One way to tackle this would be to require transparency and traceability on plastic chemicals and chemicals in products. And then we also can agree that there's a huge complexity when it comes to plastic chemicals. I showed you that sometimes we have hundreds of different chemicals for the same function, like flame retardants or antioxidants and so on. And here the question really is, do we need so many different chemicals to all fulfill the same function? So our recommendation would be really to simplify plastics, to reduce the number of different chemicals and additives and so on, which will help with many other aspects as well, like recyclability and so on. And then finally, the fourth recommendation, I can't stress this enough. This is based on the fact that there is very little understanding of chemicals, of plastics as a material. There's an institutional capacity lacking in many countries of the world, especially the low and middle income countries. And so we think it's absolutely paramount, very, very important to build capacity to educate people on chemistry, on plastic chemicals, to create safer and more sustainable plastics. As a scientist, I strongly believe that if people really understand what these materials do to their health, then people will also demand other options. So these are my co-authors on this PlastChem report. This is the lead of the project, Professor Martin Wagner from the Norwegian Technical University in Trondheim, and all my other colleagues. And I would like to thank the Research Council of Norway for supporting this work. And you can find the full report with 300 pages of technical annex online. It's all available online. And also the database of the 18,000 plastic chemicals is freely available. Great. So now let's look at plastic chemicals and health. I'll give you a very brief update on the science. And we'll start with the fact that humans are widely exposed to hazardous plastic chemicals from food packaging. That's what I want to focus on right now. So this is a recently published new data set that we here at Food Packaging Forum released in September. It's called the FCC Human Database. It's freely available online. I can put a link in the chat also for you to take a look at. And here we found that at least for 1,300 plastic chemicals, we have empirical evidence that they have been detected in people. And this is from food contact materials. And this includes many chemicals that are CMRs and EDCs. And of course, a whole bunch of these chemicals actually have no hazard data at all. And what we are seeing now is very robust data showing that some plastic chemicals of concern are associated with non-communicable diseases, which have been increasing globally over the last few decades. So I will show you some recent findings. This is an article by colleagues of mine and myself here from Food Packaging Forum, where we looked at chemicals that are known to be associated with breast cancer or that are thought to be likely to be associated with breast cancer, a kind of new approach to identify these. And we base this on a study recently published by colleagues from the United States, Silent Spring Institute, that identified 921 potential or known human mammary carcinogens. We compared this to our own list of known food contact chemicals. So this is plastics, but also for other materials. And we found 198 of these chemicals to be potential mammary carcinogens. And of these, 140 are found in plastic food contact articles, including these here. And I just want to highlight this chemical here, Erganox, which is an antioxidant. This is another study published by colleagues from Australia at Minderoo Foundation, who carried out this umbrella review of some plastic chemicals and their impacts on human health. And this is very robust evidence for human health impacts of some of these plastic chemicals. So there's basically three groups of chemicals that we're very concerned of, which are the phthalates. I'll just skip through this real quick. Bisphenols, and the per- and polyfluoroalkylated substances, and PFAS. So I just want to point out a recent publication where we show a link between ultra-processed foods, which are highly processed foods with high sugar content, high fat content, high salt content, and plastics. And so from this study, we have, again, 4 recommendations for policymakers negotiating the Global Plastics Treaty. The first of them being that they should not just zoom in on one single issue. In the context of plastics, we really need systems thinking to move us away from unhealthy practice that we have right now. So the other 3 recommendations from this article are to support and encourage interdisciplinary research between different scientific experts, to define, hopefully under the Global Plastics Treaty, criteria for what are safe and sustainable plastics. And then finally, to not ignore this emerging issue that's receiving more and more attention in the health research space of commercial determinants of health. What is the role of marketing in the overconsumption of unhealthy foods and related to that of more and more plastic packaging? So I think this is very important as we go to Busan and beyond. We have to understand that we are dealing with conflicting goals here. On the one hand, we want to reduce resource consumption, we want to protect the environment, but at the same time, that also must not affect human health protection. And there's 2 areas that I just want to highlight here briefly. Increasingly, we see people advocating for the use of biodegradable and compostable packaging, ideally made from renewable resources, not from fossil carbon feedstock. But if we don't do this carefully, we may end up spreading hazardous chemicals in the environment, such as the PFAS. So this, and also looking at the additives that leach from biodegradable plastics, for example, that there really needs to be quite a bit more attention paid in this area. And I already mentioned recycling of plastics. And this is also an issue for substitute materials like paper, which can also absorb hazardous chemicals, contaminants. This is also something that should not just be promoted blindly. And just to give you an example, in Switzerland, actually, there's a ban on using recycled paper for direct food contact, for food packaging applications, because recycled paper is full of known hazardous chemicals. And I think we need to be much more careful with recycling plastics, at least when we use it for food packaging. Great. So with that, I think I'd like to use the rest of the time now to speak about chemicals in the Plastics Treaty and just give you a very, very brief overview. So right now we have 2 treaty texts. This is the compilation of the draft text after INC 4, which is 73 pages and pretty much everything in brackets. And since this is not feasible to negotiate the treaty until the end of the year, when there's so much undecided, the chair of the INC has held several meetings with heads of delegation close to observers, so I was not party to that. And the chair has also published a 3rd version of a so-called non-paper, which is basically an alternative treaty text. So just to give you an overview, importantly, there right now is no text proposal for issues that the chair considers contentious, so where there's no alignment or consensus. But the issue of chemicals is still part of this alternative treaty text in the non-paper, just without an actual article already written out. The good news is that the issue of health seems to have gained a lot of momentum over the last 2 years of negotiations, and there's actually a draft article text now in the chair's non-paper. So this is a bit of an analysis, a deep dive into these issues, which we don't really have time to look at this. But I will be happy to speak about this if we have time during the discussion. The chemicals and the health aspects here. I'm just jumping through these now. So just to end up, what are the key points from my point of view for a health protective plastics treaty? So a treaty that protects health will address health. It will address plastic chemicals and polymers, including micro and nanoplastics. And it will do this across all life stages of plastics. So not just looking at the end of life, and also not just looking at chemicals in products, but really also looking at what I showed you at the beginning, from extraction, transport, manufacturing, use to end of life. This is really important. And it will implement modern science to enable us as humanity to shift to a future-proof path forward. And I mean with that, by taking approaches such as grouping to ban chemicals of concern, or to have different ways of testing chemicals so that we can screen plastic chemicals much faster for or even materials actually for whether they are hazardous or not. And importantly, and I can't stress this enough, the treaty must ensure that conflicts of interest are appropriately addressed. And that means that there needs to be a strict conflict of interest policy that is also enforced strictly for the scientific subsidiary bodies. So we published a scientific article commentary on this exactly a year ago, and you can read the recommendations here for the treaty. So I think to end here, I just want to mention that we need to properly test plastic chemicals for their impacts on increasingly prevalent chronic diseases. And we also published a vision on how to do this. And I will be happy to discuss this and also to collaborate with anyone who's interested in this. And I think it's also really important to stress here that we have to have measures in the treaty to avoid regrettable substitutions, so that we don't take plastics and replace it with alternatives and substitutes that have not been properly tested using modern science. And to avoid that, at least to a certain extent, we have this free online tool called the Understanding Packaging Scorecard. So before I end, I would just like to point out that I'm a member of the Scientist Coalition. I know that there's also at least one colleague in the call with us today. In case you have not heard of the Scientist Coalition, we're a global self-organized coalition of more than 400 scientists working on plastics with expertise in many different areas. And we have many resources that are intended to inform negotiators and observers during the negotiation process for the Plastics Treaty, and I invite you to have a look at these. And with that, I would like to thank you very much for your interest, and a huge thank you to the interpreter. And I think you're not done yet. I think we will take some questions now. So thank you so much.